Welcome to the TOEFL listening section. In this part, you will hear one or more conversations in an academic or campus context, such as a discussion between a student and a professor or between two students. You may take notes while listening. Listen to part of a conversation. You will hear it only once, so listen carefully. After the conversation, you will answer questions about what you heard. Some questions will ask you about main ideas and details. Others will ask about implied meaning, speaker attitude, or how ideas relate to one another. Use both what is stated and what is implied to answer.
Good afternoon, Dr. Alvarez. Thank you for meeting with me during office hours about my project on GIS applications in disaster response.
Good afternoon, Mark. Tell me what aspect of real-time mapping for emergency management you want to focus on.
I want to design a workflow for rapid situational awareness during floods. I am thinking about integrating satellite imagery, UAV photos, and crowdsourced reports for real-time maps.
That is a good combination. For flood response, you will need a clear data ingestion pipeline. How will you handle different formats and coordinate systems from those sources?
I plan to reproject everything to a common coordinate reference system at ingestion, and to store raster and vector layers in a geodatabase. I am concerned about latency.
Latency is critical in emergency management. Consider using tiled services for base maps and streaming vector tiles for dynamic features. Also plan for an automated geoprocessing step to produce flood extent polygons from elevation models and satellite imagery.
When you say automated geoprocessing, do you mean using change detection algorithms on near real-time imagery to delineate water extent?
Exactly. Simple spectral indices can identify water in multispectral images. Combine that with a digital elevation model to refine inundation extents. Machine learning classifiers can help when the water is turbid or when clouds obscure parts of the image.
I have access to daily satellite feeds and drone imagery from the field team. How would you recommend blending those for the map dashboard used by incident commanders?
Use multi-scale visualization. Show quick, low-resolution satellite-derived inundation as a preliminary layer. Then overlay higher-resolution UAV orthomosaics for verified areas. Use dynamic symbology to indicate confidence levels. Incident commanders need both speed and an indication of uncertainty.
Confidence symbology makes sense. What about integrating crowdsourced data and social media reports into the dashboard without overwhelming analysts with noise?
Filter crowdsourced reports by geolocation accuracy and timestamp. Use natural language processing to identify credible reports. Then aggregate validated reports into heat maps or incident clusters. Maintain provenance metadata so responders know the source.
You mentioned provenance. I think metadata is often ignored in emergencies, but it seems crucial for trust.
Yes. Every layer should include metadata fields for source, acquisition time, processing steps, and accuracy. That supports interoperability when multiple agencies share maps through web GIS services like WMS and WFS.
Interoperability is a good point. In real incidents, different agencies use different platforms. How do we ensure consistent symbology and feature definitions across platforms?
Adopt common data models and use shared services. For example, publish standard feature layers for critical infrastructure, shelter locations, and road closures. Use style templates and assemble libraries so that the same meaning is shown even if the client is different.
I am working with a local emergency management office. They want routing and evacuation modeling included. How does GIS support that in real time?
Network analysis can compute optimal evacuation routes by combining traffic sensors, road closure layers, and flood depth data. Real-time traffic and sensor feeds update travel time attributes. You can also run accessibility analysis to identify populations at risk who may need assistance.
Should I include demographic layers and locations of vulnerable populations in the dashboard?
Absolutely. Population density, age distribution, and locations of hospitals and nursing homes inform prioritization. Use raster population models and vector point data for facilities. Remember to handle privacy when using sensitive attributes.
Privacy is a challenge when using crowdsourced mobile data. I will anonymize records and use aggregated heat maps rather than showing individual traces.
That is best practice. Data aggregation reduces privacy risk and improves readability for decision makers. Also consider edge processing on mobile devices to pre-filter data before sending it to the server.
What about using LiDAR for damage assessment after an earthquake or a landslide?
High-density LiDAR can reveal building deformation and slope changes. Combine pre-event and post-event point clouds for change detection. This supports rapid damage classification and helps prioritize search and rescue operations.
Are there examples where GIS dashboards significantly improved response outcomes?
Yes. During a major flooding event in a coastal city, an integrated GIS dashboard that combined tide gauges, rainfall radar, and urban drainage models allowed agencies to pre-position pumps and route responders away from inundated corridors. Another example is the use of UAV imagery and rapid mapping in a recent wildfire to guide evacuations and resource allocation.
How do we validate automated products quickly so responders can trust them?
Implement a verification loop. Field teams should be able to submit validation points via a simple mobile app. Use those points to update confidence metrics and retrain classifiers. Also visualize validation results on the dashboard so analysts see what has been confirmed.
I plan to prototype using open-source tools like QGIS and GeoServer, and then deploy parts on ARCGIS Online with the emergency management team. Is that a reasonable approach?
Yes. Open source is great for custom geoprocessing and server-side services. Commercial platforms are useful for quick deployment and user management. The important thing is to design modular services so components can be swapped if needed.
One last question. In a time-constrained response, what is the single most important GIS capability to prioritize?
If you must pick one, prioritize rapid, accurate situational awareness. That means timely ingestion, automated extraction of hazard extents, clear uncertainty communication, and a simple dashboard for decision makers. Everything else supports that core capability.
That helps me focus the project. I will draft the workflow and include examples for flood and wildfire scenarios, with validation procedures and data privacy measures.
Good. Send me your draft and include case study references and sample symbology. We can then test it with the Emergency Management Office next week.
Thank you, Dr. Alvarez. I will email the draft by Monday and prepare a quick demo of the dashboard.
You are welcome, Mark. I look forward to seeing your prototype and how you operationalize real-time mapping for emergency management.
Listen again to part of the conversation, then answer the question.
If you must pick one, prioritize rapid, accurate situational awareness.
This concludes the conversation portion. For more TOEFL practice tests and study materials, visit spinta.org.